Hello everyone, welcome you all with another session of Science with Stuti Academy. In previous class, I have started with new chapter Acid, Bases and Salt, which is chapter number 2 of chemistry. Now today I'll continue with the same chapter. First, I'll do recapitulation of the previous class so that whatever I'll teach you today, it will be more clear to you. In previous class, I've explained about acids. There are some properties of acids which I have already discussed with you, like they are sour in taste, they turn blue litmus to red, and when they dissolve in water, they release hydrogen ions. So these are few properties of acids. Okay, and examples of such acids are sulfuric acid, acetic acid, nitric acid. So these properties I have already discussed with you yesterday. Apart from that, we have already discussed about types of acids. That acids are broadly classified into natural and mineral acids. Natural, which found naturally, where their source is nature, and such type of acids are called natural acids. Example of such kind of acids are methanoic acid, acetic acid, oxalic acid, citric acid, uric acid, tartaric acid. So all these acids I have already discussed with you in previous class, and this is a table I told you earlier also. Please learn this table because so many questions can come on basis of this table, like which acid is present in which food item. So you should know name of the acid and the food item and the source of that acid in which it is present. Then mineral acids also we have discussed, the acids which we get from minerals. They are man-made or synthetic. And examples of such kind of mineral acids are hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, and phosphoric acid. And on the basis of strength, earlier we classified acid on the basis of their origin, at natural and mineral acids. Now, how we classify acids on the basis of their strength? They are strong acids and weak acids. If acids dissolve in water and they produce large number of hydrogen ions, so we call them strong acids. And if acids are partially ionized in water, so we call them weak acids. An example of such weak acids are acetic acid, carbonic acid. These are the examples. And when we dilute acid by adding water in it, the percentage of hydrogen ion decreases. On the basis of presence of hydrogen ions, we classify acids into different categories. Like if you remember that I have discussed with you, monobasic acids, dibasic and tribasic acids. These acids are classified on the basis of presence of hydrogen ions, and on the basis of concentration we have dilute acids and concentrated acids. So I hope all these classification of acids are clear to you. Then we have started with chemical properties of acid. Earlier, which I have discussed, those are the physical properties. Now I'll start with chemical properties of acid. What will happen if an acid reacts with some other substance? And what are those substances? How they will react? What are the products formed when they'll react with them? So this I'll discuss in detail with you. First is, when acids react with metals, then it results in the formation of salt and hydrogen gases evolve. So when any acid reacts with metal, it results in the formation of salt and hydrogen gases evolve. Let's see examples of such kind of reaction. First is zinc. Zinc is a metal, as you know very well. It's not zinc sulfate, it's zinc only. So when zinc reacts with hydrochloric acid, it results in the formation of zinc chloride, which is a salt, and hydrogen gases evolve. So this is what happens when any metal reacts with acid. So example of such kind of reaction is when sodium is highly reactive metal. If you remember reactivity series, so if sodium reacts with sulfuric acid, this is sulfuric acid, H2SO4. When they both react with each other, it results in the formation of sodium sulfate, which is also a salt. And again, hydrogen gas is evolved. So whenever metals react with acid, it always results in the formation of salt and hydrogen gases evolve. And these are the examples. Many more examples are there. How can you detect the presence of hydrogen gas? When we are performing any reaction, we are saying hydrogen gas is evolved, but we can't see that gas. How can we detect its presence? So there is a test for the detection of presence of that hydrogen gas when any reaction is taking place in which hydrogen gas is evolved. And how do we perform this test? Let's see here. Take any metal and then add acid into it. So when acid and the metal react with each other, it results in the formation of salt and hydrogen gases evolve. Then wherever that reaction is taking place, you just take a matchstick, burning matchstick. Okay, when you take that burning matchstick, then a pop sound is produced. Whenever there is any reaction taking place in another beaker, just place that matchstick on the top of that beaker or test tube, whatever apparatus you are using, and when some pop sound is produced, that presence of pop sound is shows the presence of hydrogen gas, or shows the evolution of hydrogen gas in that reaction. So here you can see in this, there is one activity. It's very important activity and you should learn it. So if zinc granules means small pieces of zinc. When we take zinc granules and then add dilute sulfuric acid, we are adding dilute sulfuric acid and zinc granules in a test tube. And then we start this reaction. Once they come in contact with each other, and the reaction starts taking place. And here is a delivery tube. The purpose of delivery tube is whatever products are formed, so it releases. And then this delivery tube ends in another beaker. Here, so when this reaction takes place, hydrogen gas is evolved. And these bubbles, as you can see here, these bubbles shows the presence of hydrogen gas. When these bubbles are produced in this reaction, and due to the production of these bubbles, you come to know, yes, some hydrogen gas is evolved. And when this hydrogen gas is evolved, it starts rising up. And when it goes in this delivery tube, it reaches to this beaker in which we have taken any soap solution. And when here again, you can see those bubbles starts coming in. And then whatever, I said earlier also, take a burning matchstick near to this tub. Then what will you observe? So you observe some pop sound is produced. As you can see in this diagram, it is shown here, this kind of sound is produced. So this shows the presence of hydrogen gas in this reaction. So I hope this activity is clear to you. So this is extremely important topic. Generally, it comes in 2 marks. How can you show the presence of hydrogen gas in a reaction? Or how can you prove that hydrogen gas is evolved when any acid reacts with a metal? So this question can come in any ways. Or how can you show the presence of hydrogen gas? And second is, how will you prove that hydrogen gases evolve when acid and metal reacts with each other. Then this is the reactivity series in front of you. And if you remember, I have already discussed this reactivity series when I was explaining chemical reaction chapter to you. So this is a reactivity series where I have placed few metals. As you can see here, when we are moving down, the rate of reactivity decreases. Okay, and as we are moving up, the rate of reaction increases. It means the metals which are placed at the top, they are highly reactive metals. And the metals which are placed at the bottom, they are least reactive. Okay, so as you can see here, and hydrogen is placed here. Just see this arrow. I think now it's clearly visible. And the metals which are placed above hydrogen, they are more reactive than hydrogen. It means when a reaction takes place, they can easily displace hydrogen because they are more reactive. And the metals which are placed below hydrogen, they cannot displace it because they are less reactive than hydrogen. Now look at this activity series. They react vigorously with water, and if you see this arrow, it means from potassium till lead, they can easily react with acids. And they react from potassium to silver, they react with oxygen. So this is how they are placed in a reactivity series. As I told you, more reactive displace hydrogen, so they'll show more reaction. They'll show reaction more rarely. The reaction takes place very quickly. If a most reactive, if a very reactive metal reacts with any acid. Let's see a few examples. As I told you, the active metals which lie above hydrogen in the activity series are electropositive. It means they have positive ions. They are electropositive in nature. And they can easily lose electrons to form positive ions. And whatever electrons are lost by them, those ions are accepted by hydrogen ions of the acid. Look here, as a result, hydrogen is evolved. Just look at this example. Zinc. When zinc dissociates, it loses 2 electrons from it. So when we pass electricity, or when we add this zinc in metal, this with acid, so it dissociates, it starts losing electron. It has a tendency to lose electron, and as you can see here, this H2SO4 sulfuric acid, so it takes these 2 electrons and form hydrogen gas. So if you see overall reaction, we'll have zinc, then 2H plus ion, zinc and hydrogen gases evolve. So it means the metals which are placed above hydrogen, which are more reactive than hydrogen, they have the tendency to lose electrons, and that's why they are electropositive in nature. And due to this electropositive nature of these metals, when they are losing their electrons, those electrons are accepted by hydrogen ions of acid, and it results in the formation of hydrogen gas. So I hope this is clear how this hydrogen gas is evolved, or why hydrogen gas is evolved. So these are the questions which can be asked in exam also. Why hydrogen gas is evolved when acids react with metal? Or how can you say that hydrogen gas is evolved when acid reacts with metal? And the answer is because the metals which are placed above in the reactivity series, above the hydrogen, So in the reactivity series, they are electropositive in nature. They have tendency to lose positive ions, and those positive ions are taken up by hydrogen ions of acid, which results in the evolution of hydrogen gas. So it's a 2-mark question and very important question. And the next is there's an activity, how can you say that different metals have different tendencies to react with acids? So here in front of you, you just see 4 test tubes are there. In all the test tubes, different metals are present. As you can see here, calcium, copper, zinc and magnesium. These are metals which are placed in different test tubes. And when we add dilute hydrochloric acid into it, that's it, that is HCl. When we add any acid, here I am taking dilute hydrochloric acid. So when we add hydrochloric acid into it, you can see the bubbles. Just see the level of bubbles in each test tube. Now tell me in which test tube you see the most probability of evolution of hydrogen gas is maximum. In which test tube? Any idea? According to you, in which test tube there is the more evolution of hydrogen gas, or the reaction takes place very quickly? As you can see in all the test tubes, calcium being very reactive in nature, so it reacts vigorously with acid, and it results in the evolution of hydrogen gas. Just see how many bubbles are produced. And if you see in magnesium, bubbles are there but less comparatively calcium. Okay, and if you see zinc, they are more or less than magnesium and calcium. And if you look at test tube in which copper is present, no bubbles are formed. You just see this reactivity series. Calcium is placed at the top, then magnesium, and then we have zinc, okay, and finally we have copper. So just see the position of these metals in the reactivity series. Most reactive metals react vigorously with acids. Unless it will take time, and if it is placed below hydrogen, no reaction takes place. Again, it's a reasoning question, it's a 1 mark question, or sometimes it comes in 2 marks as well. So here when you add calcium, copper, zinc and magnesium, just look here, calcium is placed at top, so reaction takes place more quickly, more vigorously. Then in magnesium, then in zinc, and then in copper, no reaction takes place. So here I'll do numbering. It is at first place, second place, then third place, and then it is at fourth place. So I hope with the help of this activity, it is very much clear to you how metals react with acids, the tendency of reaction of metals with acids, how they are reacting. Okay? Or sometime in exam, they'll ask this activity also, or they'll ask question like this, suppose copper and zinc, they react with dilute sulfur, this HCl or hydrochloric acid. In which of the following test tube the reaction takes place, and why the reaction does not take place? So in any form, the question can come. So you have to answer accordingly. If they'll ask why, then you have to give reason. And if it comes in 1 mark, in which reaction takes place, in which the reaction doesn't take place, then you have to answer accordingly. So for that, you need to learn reactivity series, because this question is completely or entirely based on reactivity series only. You should know which one is more reactive and which one is less reactive. So now children, reactivity series is extremely important, because we are using this reactivity series in chemical reaction chapter also, in this chapter as well. So it's very important, and please learn it. Now, second chemical property of acid is when acids react with metal carbonate. See, when metal carbonates are reacting with acids, it again results in the formation of salt. But here, this time, there is no evolution of hydrogen gas takes place. This time, carbon dioxide gases evolve. Okay, there is an evolution of carbon dioxide gas and plus water is there. So this is how when acid react with metal carbonate, so this type of reaction takes place. Let's see some examples. First is when sodium carbonate reacts with hydrochloric acid. It results in the formation of sodium chloride, which is a salt again, carbon dioxide gas is evolved, and water. So, sodium combines with its HCl, it results in the formation of sodium chloride, and this carbonate results in the formation of carbon dioxide gas, and this H2 combined with one oxygen of this carbonate, and it results in the formation of water. I'll just explain this reaction. Na2CO3, which is sodium carbonate, 2HCl, which is hydrochloric acid. It results in the formation of salt, which is sodium chloride, and carbon dioxide gas is evolved plus water. Okay, this is how a reaction takes place when metal carbonate reacts with acids. Now look here, as I told you, sodium can easily displace hydrogen and combines with this chlorine, which results in the formation of sodium chloride, which is a salt. Okay, now here carbonate CO3 is there, so CO, only two oxygens, so CO here, it becomes carbon dioxide gas, and one oxygen is left here, which combines with this hydrogen. It results in the formation of water. I hope this reaction is clear to you. When acids react with metal carbonates, it results in the formation of salt, carbon dioxide gas is evolved, and water is formed. Let's see more examples. Here we have calcium carbonate. When calcium carbonate reacts with sulfuric acid, let's see this reaction as well. So when this calcium carbonate reacts with this sulfuric acid, it results in the formation of calcium sulfate. Look here, it displaces hydrogen because it is more reactive than hydrogen. Let's recall reactivity series, and it becomes calcium sulfate. Again, one oxygen, two oxygen from carbonate, and one carbon from this carbonate. It results in the evolution of carbon dioxide gas, and one oxygen which is left behind, it combines with hydrogen, which results in the formation of water. So I hope these reactions are clear to you. These are extremely important reactions, and questions can come in exam on the basis of these reactions. Now one more example of such kind of reaction is this one, when nitric acid, and the formula of nitric acid is HNO3. When it combines with sodium carbonate, so here again sodium replaces hydrogen and it becomes Na2NO3, which is sodium nitrate. It's a salt. And then and then this sodium, this hydrogen, again this hydrogen combines with one oxygen of this carbonate and it becomes water. And again this last is again carbon dioxide gas is involved. So these are different reactions in which the acid reacts with metal carbonates. It results in the formation of carbon dioxide gas, water and salt. So I hope these equations or these reactions are very much clear to you. Now, third chemical property of an acid is reaction of acid with hydrogen carbonates, or we call them bicarbonates also. Look at the examples of such kind. See, when acids react with hydrogen carbonates, again it results in the formation of salt, carbon dioxide gas is involved, and again water is formed. So this reaction is similar to that of carbonates, metal carbonates. Okay. Now they both are same products are formed. Look at the examples of such kind of reactions. Here you can see sodium bicarbonate. When it combines with sulfuric acid and the NaH, or we call it sodium hydrogen carbonate. We call it sodium hydrogen carbonate also due to the presence of this hydrogen. So we call it sodium hydrogen carbonate. Okay. And sulfuric acid. It's a strong acid. So when they both react with each other, it results in the formation of sodium chloride, which is a salt. Again, there is an evolution of carbon dioxide gas and water is formed. So these are the reactions takes place when acids react with metal carbonates, hydrogen carbonates or bicarbonates, or when metals react with acids. Now again, very important question, how can you test the evolution of carbon dioxide gas? See, in your junior classes, you people have studied about when carbon dioxide gas passes through a lime water, it turns milky. So again, this is the same test which I am going to discuss with you here. When carbon dioxide gases evolve, and when we pass this carbon dioxide gas which is evolving, and when we pass it through the lime water, the color of lime water turns milky. And when it turns milky, it shows the evolution of carbon dioxide gas. So this test shows that some carbon dioxide gases evolve in that reaction. So this reaction is evolved because of the reaction of acid with metal carbonates or hydrogen carbonates, which turns lime water milky, and it results in the formation of white precipitate of calcium carbonate. That white color which I am talking about, which turns lime water milky, that white color is due to the formation of a precipitate which is calcium carbonate. So look at one example of such kind. When calcium hydroxide combines with carbon dioxide gas, it results in the formation of calcium carbonate plus water, or calcium carbonate, carbon dioxide and water. It results in the formation of calcium hydrogen carbonate. So if excess of carbon dioxide gas is passed through lime water, it makes milky color of lime water disappears. That lime water starts disappearing. This is due to the formation of this calcium hydrogen carbonate, because it is soluble in water. And this calcium carbonate is not soluble, so it deposits, it collected as a precipitate. So it is white in color. But being soluble in water, it can easily dissolve and the solution becomes clear. So this is what happens when the evolution of carbon dioxide gas takes place and if we pass more carbon dioxide gas through this calcium carbonate, so it results in the formation of calcium hydrogen carbonate, which makes or which turns the solution clear due to its soluble nature. I hope this test is clear to you. And if you have any doubt in this, you can ask. These are very important topics. Now, if we are talking about acids, all acids, whether they are weak acids, whether they are strong acids, and whether they are mineral acids, natural acids, dilute acid, concentrated acids, monobasic, dibasic, or tribasic, whatever type of acids are there, they all have some common, properties in them. And what are those common properties? Let's discuss. The acids give hydrogen gas when they react with metal. This shows that all acids contain hydrogen. So whether they are strong, weak, or any type of acid it is, they all contain hydrogen. So this is first property of this, what is common in all the acids. And let's look at the examples of such kind. Hydrochloric acid, sulfuric acid, nitric acid, and all these acids, they have hydrogen common in them. Now, if you look at these acids like acetic acid, I'll just write the formula of acetic acid, CH3COOH. Just see, although it's a weak acid, but still it contains hydrogen. So all these acids are one thing in common in them, which is the presence of hydrogen. And when we dissolve any acid in water, as I told you earlier, it dissociates hydrogen. The level of or the percentage of hydrogen ions decreases, which is common in all acids. It means if we are adding water in acids, the number of hydrogen ions decreases because of the dissociation of hydrogen ions. They start breaking, and this shows that they are acidic in nature. And examples like hydrochloric acids, when it dissociates, it means when it breaks. So it gives hydrogen ion and chloride ion. Look at this example. This is hydrochloric acid. So when it dissociates or it breaks, it results in the formation of hydrogen ion and chloride ion. Let's take another example. Although it's a strong acid, and acetic acid is a weak acid. But just see, here also we have hydrogen ion, here also we have hydrogen ion. So again, it means if an acid is strong or weak, they all contain hydrogen ions. Look at this example of acetic acid. So when it dissociates, it results in the formation of acetate ion. Plus hydrogen ion is also produced. So all acids have some common points in them, which are they contain hydrogen, and when they dissolve in water or when they dissociate, it always results in the formation of hydrogen ions. Now, what kind of questions can come in exam on the basis of this topic which I have discussed till now? Like, first is name the gas evolved when dilute HCl, which is hydrochloric acid, reacts with sodium hydrogen carbonate, and how is it recognized? And the answer is hydrogen gas. Which gas is evolved? Again and again I am saying, when acid react with hydrogen carbonate, so it results in the evolution of hydrogen gas. And how can we recognize it? It is due to the evolution. When hydrogen gas is evolved, pop sound is produced. This pop sound shows the presence of hydrogen gas in that reaction. Right? Now next is Name the acid present in the following. First is tomato, then vinegar and tamarind. So oxalic acid is present in tomato, and in vinegar, acetic acid is present. In tamarind, tartaric acid is present. And all these acids are natural acids. So their source is natural. They are present in food items. Okay. Then name the natural source of each of the following acid. Just see these two questions. Here, food item is mentioned and they are asking about the name of the acid. In this, name of acid is given and then you have to tell in which food item it is present. So here, citric acid, first is citric acid, it is present in lemon and orange, present in all citrus fruits. And we call these type of fruits are citrus fruits, which are sour in taste. As I told you, all acids are sour in taste. But we cannot taste all the acids. We can taste only organic acids, natural acids, which are present in food items. And oxalic acid is present in tomatoes and guava. Lactic acid is present in curd. We prepare curd from milk, and the property of curd is entirely different from that of milk. Tartaric acid is present in tamarind. So, next is explain why is hydrochloric acid a strong acid and acetic acid a weak acid. How can it be verified? So this question is based on a number of this hydrogen ions or the dissociation of these hydrogen ions present in the acids. If you look here, HCl, which is hydrochloric acid, it completely ionized in aqueous solution. And what is aqueous solution? Any idea? Which type of solutions are known as aqueous solution? Those solutions which are soluble in water, which can easily dissolve in water, the substances, they make the aqueous solution. Okay. So, when acid completely ionized in aqueous solution, so they are known as strong acids. If they are partially ionized, so we call them weak acids. So here, when we, although I'll discuss this topic, this second part with you, how can it be verified? Because I have not discussed yet pH paper. One pH scale is here, which detects whether the acid is strong or weak, whether a particular acid is strong or weak. So there is a scale that I'll discuss later. So if HCl being strong acid, so when we pour a drop of this acid on a pH paper, it gives dark red color. More darker color, it means more stronger that acid will be. And if less color shades of red are there, it means they are weak acid. So when we pour a drop of acetic acid on pH paper, it gives orange color. So I'll discuss this pH paper later with you. And then second is explain why aqueous solution of an acid conducts electricity. Because as you know, electricity is produced when there are charges, free electrons are there. So here it is because acid ionizes in aqueous solution, and as a result free charges are there, and these ions have the ability to conduct electricity. So that's why when acid dissolves in aqueous solution, it conducts electricity due to the ions which are produced. I hope this is clear to you. These are the important questions which I have discussed. These type of questions comes in exam, and they all are reasoning questions. So whatever I taught you, just revise it. Just revise the entire topic and go through each and every question in detail. And if you face any problem, then I'll discuss those problems in next class.